This is section 3.2 part 3, and we are still solving linear systems. And back when we graphed, we saw a scenario when we had infinitely many solutions. When we had infinitely many solutions, it was the same equation that was graphed twice, and it looked like one line because it was the same line over itself. When you're using elimination and substitution, you still can have the scenario of no solution or infinitely many. So we're going to look at the idea of infinitely many first, and then we'll do no solution. So you can choose either elimination or substitution here. I am going to choose substitution. It's a two-step process, and that's the reason I want to show it to you. Sometimes you might need to do substitution, and you don't see that you have a y all on its own. I do have a y here, but it's not a positive y, it's a negative y. Alright, so I'm going to try and solve this second equation for y. It's going to take two steps, and then I'll be able to substitute in. So, first things first, alright, I'm going to take this equation, 3x minus y equals 2. I'm going to bring over the 3x. So I'm going to subtract 3x from each side. And I've got the opposite of y equals negative 3x plus 2. Can't leave it like this because of this negative. So I'm going to divide both sides by negative 1. And I'm going to see y equals positive 3x minus 2. So I've taken the second equation, I've manipulated it, reworked it, and solved for y. So with substitution, you have to use the unused equation. Alright? So I'm going to use my unused equation of 9x minus 3y equals 6. And remember, y equals 3x minus 2. So I'm going to replace this y with 3x minus 2, because y and 3x minus 2 are exactly the same, so you can replace it once it's exactly the same. So I've got 9x minus 3, and instead of y, I'm going to write 3x minus 2 equals 6. Simplify, so I've got 9x, distribute in the negative 3, so I've got minus 9x, distribute in the negative 3, and I have positive 6. What happens here? 9x minus 9x. Looks like my variables cancel. So when they cancel, you're going to be left with two numbers. In this scenario, we see 6 equals 6. The two numbers equal each other, which is true. When that happens, your variables are gone, you know you're going to have infinitely many solutions. If your variables canceled, and you had two numbers on both sides of the equal sign, and they were not the same number, you wouldn't have infinitely many solutions, you would have no solution. Alright, so that's the difference. In both cases, the x or the variable will cancel. Alright, just you have to analyze what's left. If they equal each other, infinitely many. If they don't equal each other, you have no solution. So what does that look like? So that's D, no solution. And let's look at a problem that occurs there. So we use substitution. Again, no solution. You can use either elimination or substitution. Doesn't matter. I'm going to end up using elimination here, just because we used substitution in the previous problem. So, no solution. We've got x minus 2y equals 5, and 4x minus 8y equals 3. With elimination, I want to add or subtract these together. But currently that's not going to be any help because the variables won't cancel. I want to either cancel the x or the y. So I'm going to try and cancel the x. Alright, and I'm going to try and get the two x's to be the same. Alright, so I'm going to multiply this whole equation by 4. So 4 times x is going to give me 4x. Negative 2y times 4 gives me negative 8y. 4 times 5 gives me 20. Since I've got 4x here and 4x here, I don't need to do anything to the next equation, so I'm simply going to slide it over. 4x minus 8y equals 3. So I've got same coefficients here, so I know I can subtract. 4x minus 4x, well, that cancels. And whoa, wait a second, I've got the same coefficients here as well. If the same exact coefficients cancel, it's probably going to do the same thing here. I've got negative 8 minus a negative 8. Remember, minus a negative becomes plus a positive. So negative 8y plus 8y, that cancels. And I'm left with 0, because everything on the left side canceled. And this is still subtraction. So I've got 20 minus 3 is 17. Two numbers, all the variables canceled. Two numbers, they don't equal each other. So we know we have no solution. And that's the end of section 3.2.